All right, let's look at number 8 here. Here you can see you have a trigonometric function, and they gave you the format of h at t equals a sine b t minus c plus d. So it's a typical ABCD question. You're given a graph, and the domain is for 13 hours. So start from 0 to 13. Now they give you a bit more information here. They give you the minimum and the maximum height. So you know the maximum height is at 6.8 meters, and the minimum height is at 2.2 meters. The first high tide occurs at 4:30. So this point, it's at 4:30 or 4.5. And the next high tide occurs 12 hours later, which means one full period here is 12 hours. Okay, so that's basically what the question is giving you. Now let's take a look at the question. Shown that b is pi over 6. So a, b, c, d. So b here is going to be related to the period. The value of b, if you remember, it's always 2 pi divided by the period of the function. Here, one full cycle is 12 hours. So 2 pi divided by 12, which give you pi over 6. So that's A. Next, we need to find letter A. Letter A is the amplitude. That's going to be the maximum minus the minimum divided by 2. So maximum minus minimum divided by 2. In this case, you're going to get 6.8 minus 2.2 divided by 2. So that's 4.6 divided by 2, you get 2.3. Next, we're going to try to look for the D value. The D value is the axis of the principal axis, the equation of the principal axis, so the middle point of the graph. So it's going to be maximum plus minimum and divided by 2. Max plus minimum divided by 2. So you're going to get 6.8 plus 2.2 divided by 2, which should give you 4.5 meters. Find the smallest possible value of C. Well, that's going to be your phase shift. Okay. So here you're shifting to the right. Now you have to check. This is a sine function. A sine function means you start in the middle. Right? See how this is a sine model? A sine model tells you that you're starting in the middle. So halfway, it's going to be, what did we calculate again? It was 4.5, right? So somewhere here is what we're looking for. Somewhere there is what we're looking for. So we're looking at like this particular point. Okay. Now we know one full cycle is 12 hours. So here, half a cycle would be 6 hours. A quarter of a cycle is going to be 3 hours. So you have a maximum at 4.5. 3 hours before that, this is going to be at 1.5. So the C value is going to be minus 1.5, right? C minus, it's at X minus 1.5. So C value is equal to 1.5 hours. Okay, let me go back again. One full cycle is 12 hours. That's top to top, a maximum to maximum, or middle to middle, right? Half a cycle is 6. That means to go from top to the middle, that's 3 hours. Top to the middle is 3 hours. So 4.5 go back by 3 hours, you're going to get 1.5. Okay, now find the height of the water at 12 o'clock. Now we have the equation already. We have the value of A, B, C, D. So to find the height at 12 o'clock, all we have to do is sub in the value for T. So let's write out the equation here. The height of the water is going to equal to A multiplied by sine B X minus C, or T minus C in this case, plus D. Okay, let me replace that with T. So that's the equation. And you want to find out the height at 12 o'clock. Now, the starting point is your start at 0, which is midnight, right? Starting at midnight. So 12 o'clock, it's going to put in 12 into the function. Sub in T equals to 12, right? So you can punch in the calculator. If you have calculated, H at 12 should equal to round up to 3/6, which is what IB wants, 2.87 meters. Now, if you have a graphing calculator, you can also solve it using a graphing calculator and sub in X value equals to 12. All right, last part. Determine the number of hours over a 24-hour period for which the tide is higher than 5 meters. So higher than 5 meters, you have the 5 meters there, and you want to know in 24 hours, right? So you see the graph here is only up to 13. So you want to go all the way to 24 hours. And you're going to see where the graph is going to be above the 5 meters mark. So maybe I'll clean this up a little bit. I'm going to raise this so that you can see it better. Okay, I'm going to put this right on 5 meters. Okay. The graph is going to be keep going. Right. We know this is 4:30. So 12 hours later is going to be 16:40 or 30. Right. And then you keep on going up to 24 hours. And you want to see how many times it's going to touch 5 meters. Right. So first of all, we need to find a point of intersection, which means we need to find this dot, this dot, this dot, and that. Okay, so you have to solve for it. So what I get is on the graphing calculator is probably the easiest way to do it. So F, the point of intersections between 0 to the domain is 0 to 24. Maybe I'll write like that. T, not X. Okay, and there are 4 solutions. About 1.92. That's a 9. About 7.08. Here about 13.9. And the last one, that's about a 19.1. Right? So they want the number of hours above. So I need to know the distance between these two and the distance between those two. Well, they're actually going to be the same distance because, you know, the shape is symmetrical. It's congruent. It's the same shape. So total, if you add this 2 up, or you can take this and multiply by 2, you should get a total of 10.3 hours. Okay. So basically this part subtract, this part subtract, add those 2, and you should get about 10.3 hours.